KJ7NL, and today I'm going to talk to you all about this desktop satellite tracker I've been working on, and the circuit board for it, back here.
Alright, Zeke, so how's the circuit board going to go on?
So the circuit board is going to basically plop right on top of this. So it's going to be a circle that sits around the edge of this, and there's going to be a little lip that holds it on, and then we're going to have some contacts that press so we can get power up to our motor in here, which goes up on top, and this is where our arrow to point at the ISS will be, or any satellite actually.
Okay, so the gearing is interesting. What do you have set up for gears?
We've got a planetary gear system which gears it down from 430 RPM to about 17, so that this thing doesn't have to spin so fast.
Okay. Why are there so many gears in there?
Well, it's two stages. So first we gear it down a little bit with that, and then we gear it down the rest of the way with the upper stage. And you'll notice if I hold this still, the motor will slowly turn, like so.
Okay, how did you make the gears?
I designed it in Tinkercad.
And then
3D printed it.
So, what do you got there, Zeke?
This is the schematic for the board that sits on top of the, for really the control box board for my desktop satellite tracker.
Okay, so tell us about the schematic. What are the major components you're using?
We are using an ESP32 microcontroller right here, and it's the brains that controls everything.
Okay.
And it has a little antenna, which is why we're using the room. And so we also have a push button for the reset button, and a couple of LEDs to light up the bottom because it's going to be clear.
What do you mean it's going to be clear?
This part here, the ring, is going to be clear.
Oh, neat. So it'll light up. You get to see the gears.
Mm-hmm.
Okay, what else you got coming?
We have our USB things here, which plug into our USB connector right here. Now the USB connector has a lot of things, and it allows us to talk to our ESP32 and be able to control everything.
So how do you turn this from the wiring into a board?
Well, that happens in the layout right here. This is the layout for the board, and this is what it will look like. We've got our little prongs that come out here to attach to, and they're sort of like springs. They just come down and they press against little contacts so we can get power up to the assembly that points at the ISS.
Okay. And now why do you need those contacts? What would happen if you didn't have them?
Then it wouldn't be able to move. There would be no power for my flexible PCB.
Can't you just connect a wire?
If we connected a wire, it would just twist all up, then we wouldn't be able to turn.
Oh, so these contacts allow you to rotate without twisting up a wire.
Mm-hmm.
Okay.
We also have our push buttons here, and they allow you to control this menu in this screen. We're going to be using one of these little screen things, and this is going to be where you're going to see all your telemetry and data for your satellites and stuff. So here's where we've put all of our USB components. We have our voltage regulator, which turns our 5 volts into 3.3 volts here. We have a couple of things here. This is an add-on GPS module that we could add if we wanted, and this is just an add-on chip that you can use if you want to get your position extremely accurate. And then we have a JTAG connector here for debugging, and our ESP32 chip here. You notice that its antenna is actually off the edge of the board here so that it doesn't get interfered with by the ground plane.
Okay, neat.
And you might notice there's a whole lot of VSN freeware, and that's one for connectivity so that the ground flood and ground fill or ground plane can be connected pretty well, and also to keep signal that's not supposed to be there out, and so it won't cause noise for other components.
Okay.
So here we have our 3D view, and our 3D view is just what this looks like. This is a representation of what the actual board will look like. We have our little components here which push on our contacts, and you'll notice they're actually battery springs, So these are what you would use for if you are designing a circuit board that needs to push against batteries. We're using that.
So what do they connect to? What do they touch?
They touch this, and this looks like this. It's just basically a little thing that plops onto our little motor here, and when you press against it with those contacts, it presses all this down, and so that allows you to use it and have it work. And you might notice these 4 contacts here, and they are for a flexible PCB. And the way it's going to work is you might notice all these cutouts in it, and that's because it has to bend wherever you see a cutout. So wherever you see a cutout, it's going to bend right there. And so here we have our accelerometer, which is going to tell us the angle and the position of the arrow, which points at our satellites. And down here we have a compass, which goes inside of this little tube here, and that compass just allows us to know the rotation when this thing spins around, accurate to within 3 degrees.
So are you going to have to calibrate these things?
So the way you calibrate is you basically just take this entire thing, you spin it around, and that's all you need to do. You turn, and for this, it will automatically do it. It'll just move the arrow back and forth, and that calibrates when you turn it on. And here's the 4 contacts which connected to the circle board right there.
Okay.
So that's that. And that is pretty much everything I have to talk about here. So that's the introduction to my circuit boards for the desktop satellite tracker.
Was that the lead out?
Thanks for watching. I hope you can enjoy my mom's laughing.